What if your AI doesn't just talk, but actually acts? Look at this. And there it is. A real database update triggered by natural language. This is the power of Semantic Kernel. In today's video, I'm going to show you how to build this exact AI agent using .NET and Semantic Kernel. Let's dive in. Let's start by creating a new .NET 10 console application. I'll keep the default settings, and we will use top-level statements to keep our code clean and simple. Now, let's open the Package Manager console and install the Semantic Kernel packages using the command line. First, we'll add the core Microsoft.Semantic Kernel library. And since we are using Gemini, we need the Google connector. Remember to include the pre-release flag as it's currently in preview. First, we initialize the kernel builder. Think of the kernel as the central hub that manages our AI services and plugins. Now, we will add the Google Gemini service. I'm using the Add Google AI Gemini Chat Completion extension method here. For the model, I'll use Gemini 2.5 Flash. It's incredibly fast and perfect for handling function calls in real time. And here we provide our API key, which I generated from Google AI Studio. Remember to keep this key secure and never share it in your production code. Before we build the plugin, we need a simple user class to represent our data structure. This will hold the user's ID, name, email, and subscription type. I'll define these as basic strings and integers. Notice how we're keeping it clean using C# auto properties. Now, let's create the UserDatabasePlugin class. Inside it, I'll define a static list of users to act as our in-memory database for this demo. By adding kernel function, we are officially exposing the C# method to the AI. Without this, the kernel won't see this function as a tool. This description is not for the developer, it's for the AI. It tells Gemini exactly what this function does. It searches for a user by name. We even add a description for the parameter. This helps the AI understand that it needs to extract a name from the user's message and pass it here. Inside, we use a simple LINQ query to find the user. I'm using ordinal ignore case to make the search flexible, so it doesn't matter if the user types in uppercase or lowercase. Finally, we return a formatted string. If the user is found, the AI will receive their details and present them nicely to the user. If not, it returns a friendly error message. Now, let's create a more action-oriented function, update subscription. Notice we have two parameters here, the user's name and the new plan. I'm adding examples like free, premium, and enterprise in the description. This guides the AI to understand what kind of values are expected for the subscription plan. The logic is straightforward. We find the user, and if they exist, we update their status in our list. This simulates a real database update operation. The string we return here, successfully updated, will be used by Gemini to confirm the action to the user in a natural way. Now imagine a user saying, "Hey, upgrade Alice to the enterprise plan." Gemini will use this specific function, extract Alice and enterprise, and execute our C# code. Let's see it in action. Now, we register our UserDatabasePlugin into the builder. This step is what makes the AI aware of the functions we just wrote. It's like giving Gemini a manual on how to interact with our database. And finally, we call builder, build, to create our kernel instance. This is the heart of our application, where the AI model and our custom tools are officially linked together. Next, we retrieve the chat completion service from our kernel. Think of this as pulling the Gemini engine out of the kernel so we can start talking to it. Then we initialize our chat history. But notice this string inside the constructor? This is our system prompt. We are explicitly telling Gemini its role. It is an expert assistant with access to our database. Giving the AI a clear context like this dramatically improves its accuracy when deciding which function to call. Let's add a quick welcome message to the console, so we know our AI assistant is online and ready to help. And it's always a good practice to give the user some example prompts. Notice how natural these phrases are. We are simply talking to our system in plain English. Now, let's wrap everything in a while loop. This creates a continuous chat experience, allowing us to have a back-and-forth conversation with the AI. We'll capture the user's input from the console and, of course, add a simple check to exit the loop if the input is empty. Crucially, we must add the user's input to our chat history. This is how the AI maintains context and remembers what we talked about earlier in the session. Now, this is where the real magic happens. We need to configure the execution settings to enable the AI's decision-making capabilities. By setting the function choice behavior to auto, we are giving Gemini the green light to automatically decide which of our C# functions to call, based on what the user asks. It's completely autonomous. Now, we finally send our request to the AI. Notice that we pass the history, the settings we just created, and the kernel itself so it can access our plugins. Once Gemini processes the request and executes any necessary functions, we print the final response to the console. This is the AI's voice after it has done its work. We also add the AI's response back to the history to keep the conversation coherent for the next turn. And of course, we wrap everything in a try-catch block to handle any potential issues, like connection errors or API limits, gracefully. Our code is complete. Now, let's run the application and see how our AI agent handles real requests. And there we go. Our AI assistant is live. It's telling us it's ready to check user info or perform updates. Let's try the first example. I'll ask Gemini about Alice. It should call our getUserInfo function now. Now the real test. I'll ask it to upgrade her plan. Notice how it understands the intent and calls update subscription automatically. Finally, let's verify the change. This proves that our AI agent successfully interacted with our C# data. As you can see, we just built a fully functional AI agent that can read and write to our database using simple English. This is the power of Semantic Kernel and Gemini 2.5 Flash. If you found this video helpful, don't forget to like and subscribe to Sarrawy Dev for more deep dives into .NET 10 and AI integration. Thanks for watching, and I'll see you in the next one. Happy coding!